Hello, welcome back to C# Tidbits. Today we will look at how to diagnose issues with loading DLLs inside of .NET Framework and also inside of .NET. For that we will use two useful tools, the Fusion++ and also Purview. If you're a little bit afraid of Purview, don't worry, it's going to be quite easy and quite exciting. So let's first look at our example. I have this missing DLL Net Framework application, and so far it's not missing any DLL. We will break it in a second. It prints the name Alice and age 30, and the code is extremely simple. We are using this serialization helper that converts the user to JSON. This helper itself is implemented inside of this additional library called helper, and we are using newtons of JSON to do the conversion. This is to simulate an application that has at least one dependency that has additional dependency. So if we now switch into the bin folder and we look at the DLLs that we have inside of our folder, we can see the help library, we can see the missing DLL Net Framework XCE, that's our main application, and then we can see newtons of JSON DLL. Now we will shoot ourselves in our lag and we will delete this DLL. This is not something that you would normally do, but if you have a deployment of an application that is missing a DLL, it will manifest with the same error. If you have a deployment of an application with mismatched versions, you will be able to diagnose it in the same way. If you will get missing method exception, it's probably coming from a library that has a mismatched version, and so you will be able to apply the same approach to diagnosing those problems as you would use and as you will see here with the deleted DLL. So I delete that DLL, I run my app, it doesn't rebuild because there's nothing to be updated, and it tells me file not found exception, couldn't load, file or assembly newtons of JSON. As expected, it also lists the version. And in this case, we know exactly what happened, but how do we figure out what happened if we didn't know? So one way to do that is by using Fusion logs, and Fusion logs have this classic UI, which is absolutely terrible. But luckily on GitHub, there is an application called Fusion++ that's free to download, and I downloaded and installed it on my local system. It's very nice that it says relax. So let's relax and we click record. We go into our app, we run it again. It again fails with the same error. I move back, I click stop, and I will see all the different DLLs in the whole system that were loaded by different items. So as I can see, something was running on the background, but I can see my app name, missing DLL Net Framework, and I can search or look for errors. And here I see an error loading newtons of JSON. That's exactly what happened in the command line. So I will double click that line. It opens the editor and it shows me very detailed information about what was going on. First thing that I want to look at is under which executable we are running. So in this line, running under executable, we see the real XCE. Then we progress with the binding, usually look for this app base to see where it's set. Typically that will be where your executable is placed. And then this calling assembly is very important because that tells us who requested this DLL to be loaded. That's why we added this one more dependency. So I'm able to show you this. And this way I know that the calling assembly is helper library, and so the newtons of JSON is dependency of this library. And if I wanted to know the exact version, I would open it in ILSpy or in some other decompiler, look at that version. I could also use the .NET dependency tool and so on. But this tells me who called this, and I have much easier time debugging why the problem happened. And then we look at the policies. So there are different configurations for .NET Framework. There is a global configuration in machine config. And there is usually also the application level configuration, which is in here, missing dlnetframework.exe.config. Those policies can define, for example, binding redirects that say version between 10 and 11 will redirect to version 13 of Newtons of JSON. Binding redirects are also typically auto-generated, so any DLL that you will get with any version will be unified and forwarded into the version that you actually should have in the bin folder. So if this is broken, if some other DLL is placed there, it will break the whole resolution. And so what we can learn here is that we applied this policy, we applied this policy, and after all the policies were applied, this is the version that we're looking for. So if there was a binding redirect, we would see here the version to which the binding redirect redirects. We also looked into the GAC, so in the global assembly cache. Sometimes if you find the DLL in GAC and you didn't expect it in GAC, that leads to interesting errors, but in this case it was not there. And then it says it's attempting to download, meaning I'm trying to find this file and use it. And so we look for Newtons of JSON DLL. We also look by convention into a folder with the same name. And because .NET Framework assemblies can also be executables, as we see with our own program, we are also looking for Newtons of JSON.exe and using the same name folder and the same name executable inside. We looked at all the probing URLs and there were no additional probing URLs defined in any of those configs, this one or this one. And so we didn't find a DLL and we failed as expected because we deleted that DLL. But for any other problem, any other missing DLL, however it came missing, you will be able to follow the same path. Sometimes if the versions are mismatched, you will get a different error. It will show you the same output, but at the end you will see the version this was found, but the major version mismatched, and that's why it didn't load. And then the data just repeat. You can read all of this in detail, but this is how we would find why this DLL was loaded, who loaded it, and which version was required. Now I said that's very important to see who is the calling assembly. In this case, it's the help library. Sometimes you have much bigger chain of dependencies, and so you want to look up this library in the Fusion log. And we can do that easily, for example, here. And we can see that it was loaded here. It was loaded without any significant problem. And the calling assembly was missing DLL net framework. So now we are on the top of the chain. We are already in the executable. So the chain of dependencies, as we saw in the project, is missing DLL net framework, help library, and then Newtons of JSON.dll. This is how you do it in .NET Framework. But how you do it in .NET, that's a very frequent question because Fusion logs, once you use Fusion++, are super useful for finding problems like this. So let's switch to my other project. I will load it. I will make it as a startup project. And this one is built with net10. And it has exactly the same code. We have a user Alice. We serialize it through the same library and we write it to the console. We can try to run it and it should be able to run because we didn't break it yet. Great, so now we have the output. And if I go back into the folder and again break my application by going into debug, net10, deleting Newtons of JSON, and run the app again, I should see a very similar error to what I saw before. So now just for fun, let's try to use Fusion++. We start it up. We click record. We run this app. it finishes, and we get no results. That's because Fusion logs are not available for .NET. So how do we do this? We will have to whip out Purview. There is luckily a lot of documentation around this, and it's called Collect Detailed Assembly Loading Information. It describes it for .NET Trace, but I never had luck using it and opening the trace afterwards in Purview. It just doesn't work for me. But luckily, this provider's concept is transferable into Purview. So I can take this name, I can open Purview, I can click Collect. I either select Collect, which will record my whole system, or I will select Run. So I will try to do Collect. It asks me to be an admin. I clicked OK. And then here in Additional Providers, I want to put Microsoft Windows .NET Runtime 4. Now if I start collecting, it should act the same way as Fusion++, just with way worse UI for this purpose. So we start, close this one, we run the app, it records the Fusion logs in quotes. We stop the collection, and now we should be able to get the output, which recorded unfortunately into a different folder, but it doesn't matter. It's here in the Purview data ETL. And I can look into events as described in the documentation somewhere on the bottom. So we look for assembly loader. And there are multiple different events. For us, the most interesting one is stop, but we will select all of them, press enter, and that will show all the events that happened within this application and any other application. We got a lot of information here, and this is extremely hard to read and extremely hard to show. So what I will do is that I select everything and copy and paste it into this new document inside of Visual Studio Code. Let me change the language mode to just plain text. And here what I'm looking for is Newtonsoft JSON. And we can see there is start of the load. That's the first event that we will get. That says, I will start finding this one. Then we get the resolutions attempted, which described where we are looking for the DLL and if we were able to find it there. And then we have the event that I mentioned, which is the loader stopped. And in this place, we see this is what we tried to resolve. And especially this is the requesting assembly that asked for this DLL. This is typically the most important information that you can get. And this way you can then trace where is that dependency coming from, what is the exact version that is required, what is the version that you actually have in the bin folder or that you are missing in the bin folder, and then figure out how do you get the DLL there. But without this information, without this logging, it's very hard to see what is being requested, who is requesting it, and what you are expecting. So this was a small peek into how to figure out why is DLL missing and who requested it. So hopefully you found this useful. Let me know down in the comments if there would be something else that you would like to see